Okay, well, are we ready to go, Malcolm?
I am.
Okay, well, good evening, everybody. I think you're all muted and we all can't see your face, which is possibly a good thing. Welcome to the CIBSE seminar for November. And this evening we have Malcolm Thomas, who is an authorising engineer and the primary author for the update and probably original HTM 03, specialising in ventilation in the healthcare setting. So I'll pass it over to Malcolm. If you have questions, if you could just lodge that in the chat area, and when we get to the end of the presentation, I'll ask Malcolm the questions on your behalf. So without further ado, Malcolm, if you want to share your screen.
Share me screen. I thought I was on, but there we go. Who knows? Turn camera on. Camera's on. I'm on. Share tray. Oh, no, can't see me. No.
Well, we can see you, but not your slides.
You can see me. Okay. Just to introduce myself a little bit, Malcolm Thomas. I probably know some of you. We've bumped into each other at some time or another. We've done what I'm going to talk about tonight is the changes from HTM 0301 2007 up to the new HTM that's just come out. It's been a long process. I want to go through the major changes, and then I'm quite happy to take questions for as long as you want them afterwards. I've got a bit of a presentation, so bear with me, and we'll go from there. So hopefully you can see that. Wave if you can.
Yep. All good.
Give me a thumbs up if you can see that. Yep.
Yeah, all good.
That's going out, okay, because once I go over the presentation, you won't be able to see you, I don't think. Right, so there we go. Oh, yes, I can. Not so bad. All right, so this is just a presentation on the changes, the key issues. First thing really is to look at a little bit of the history of why we've come from where we are. A lot of people seem to think we start off with HTMs with a clean sheet of paper, but we don't. They're based on what we know in the past. 55, strangely enough, which is some of my age is not so long ago, God help me. Nuffield, the health service when it set up in 47, acquired an awful lot of hospitals, buildings all over the country. Some of them were actually designed as hospitals, but many of them were hospitals created for the First or the Second War, or they were care homes, or the Lord of the Manor gave their stately home because the town had got too near to it as somewhere for wounded soldiers in the First and the Second War to go and recover, and they became hospitals. So we ended up with a real mismatch when the health service was found. And Nuffield were tasked with looking at this and saying, well, what's best practice? What actually do we need? We're no longer in a war. What's a sensible hospital system? What about the design of them? And they produced a report, and it's well worth, if you're interested in hospitals, it's well worth finding a copy and reading it. You can get one from the British Library. It's no longer in print. But it ran through on what was a good idea and a bad idea. And from that, in 1964, the Department of Health produced a series, or Minister of Health it was at the time, a series of building notes based on that. So if we're going to build and renew our hospital stock, this sounds familiar, doesn't it? What's a good idea? What's a bad idea? And they'd looked all over the world at what was a good and a bad idea, what seemed to work and what didn't seem to work. And that was the foundation of all the guidance the health service ever produced ever since. In terms of operating departments, the ventilation bit was one page at the back of the building note, but it soon became apparent that that wasn't enough. A lot of hospitals were built or converted, but there were major problems with them with infection rates. And a chap by the name of Owen Lidwell, Professor Owen Lidwell, Dr. Owen Lidwell, sorry, was tasked with looking at hospitals and operating suites and finding out why it was that some hospitals, when you went in for an operation, you had a good chance of coming out alive, and even better, without any infection or any ill effects. Whereas other hospitals, you had perhaps a poor chance of coming out better than when you went in. And he looked at all sorts of things. He looked at the operating teams, the facilities, and all sorts of things, and he came up with a report in 1972 on operating suites, what was good and bad, what worked and didn't work. And he did an awful lot of investigation on it, good science. I've got some of his test equipment, actually, which I can't show you because it's in Britain and I'm in Germany at the moment. But he found out what worked and didn't. And it's the origin of the famous 20 air changes an hour, because he found that was about enough. It isn't that 20 is a sort of some sort of sacred number, which if you have 19, it's no good, and 21 is better. But around 20 air changes an hour seemed to be enough to ensure that as long as you had a competent operating team, you were unlikely to get an infection during the operation from the airborne route. This all led to a working party by the Department of Health at the time, and they produced a document called DV4, data sheet number 4, just on the ventilation of operating departments in '83. That was really when I started to come into this, because I was asked sometime later to update that document, and that came out eventually as HTM 2025 1994 in 4 parts. Bit of a tricky document, 2025, because I'd started off by being asked by the department to update DV4, which I did, and I just finished that, and I was told, can we now split it into 4, because we want to put it out in 4 parts, each part aimed at different groups. And that's why it was one of those things you think, well, if you'd said that in the first place, we'd have done it something completely differently. But they didn't. They gave us about 2 weeks to split it down into 4 parts. And we got left then with HTM 2025. It wasn't too bad, but there were gaps in the guidance, and there were overlaps, and there were some anomalies in it. So it wasn't as complete as I would have liked it to have been, let me put it that way. And sadly, a lot of the PFI projects were based on that document, and it was never, ever intended to be a briefing document for building hospitals by people who didn't know about hospitals. It was intended to be a document for, those of you who remember back in those days, for the major construction companies in the country who all had teams of people who regularly built hospitals. So it was a prod in the ear to people who knew, not ease guide for people who didn't know. But as some of you are probably aware, when a lot of the PFIs were built, the project teams were pretty thin on knowledge. There was a big financial incentive to bid for these things, and having got the job, then people cast around to find someone to do the design, not always successfully, I'm afraid. All that led eventually to a revamp of that HTM, and we had HTM 0301 in 2007, which was written as starting from the basis we were going to write an HTM, so I think it came out slightly better. Documents look like this. Owen Lidwell's, Dr. Lidwell's document. DV4, some of you might still have that in your bookshelf, still very good. A lot of it's still very relevant. 2025 when it came out in '94, and then HTM 0301, which was the new versions of HTMs that were published about then, taking us into this millennia. In 2007, there was a big drive to revise HTMs, and HTM 0301 was looked at. One of the problems that kept coming up was the effects of litigation, healthcare-acquired infections, in that there were a number of cases coming to court, and they continue to, unfortunately, where people went into hospital with one thing and they came out with something else. And there's quite a bit of fuss going on at the moment. You might see in the news tonight, similarly going on. So it then came down to, well, if somebody went in a hospital with one thing and came out with something else, why was that? Was it a failure of nursing care? Was it that they weren't in an appropriate facility? It wasn't ventilated, perhaps. And there were arguments about that. And then you go back to the source, the HTM. Is it clear enough about what's required? Well, maybe not. So that was a driver. International standards, as you're all aware in your game, indoor air quality. The WHO document on indoor air quality had come out. There was a big push about the air we breathe in, the air we bring into buildings. What quality was it? What quality was it inside the building? The filter specification changed dramatically. I'm not sure for the better, to be honest. It's very confusing now. If those of you looked at trying to specify filters, we had a fairly simple, straightforward system that seemed to work, and now we've got a very complicated one that's hard to understand. However, we are where we are. The system efficiency, our specific fan power, the whole thing about how much energy we use. And there's new technology available for fans, so were we using it correctly? The eco-design regulations that are now out, the energy-related product regulations, that came out as well, and plainly we needed to reflect that. The fact that energy recovery was seen now to be something that was a default position. In the past, it was always you could put energy recovery in if you could prove that it would pay for itself, and now you'd have to prove it doesn't pay for itself not to put it in. So the default position is you will have it. And the F-gas regs, the whole thing about phasing down refrigerants, which has got a major impact on how we do cooling in future, the use of split units and so on, we can see diminishing because of it. The fact that refrigerants are considered not good things to have, and we need to address that. So there's quite a lot of things there that came up that needed to be sorted. Looking forward, healthcare delivery. The way we deliver healthcare is changing quite dramatically. There's a huge increase in what we call interventional imaging, which is instead of a doctor just prodding you and thinking, well, I think I'll take a knife and open you up and see what's wrong with you. No, we can now scan you in 3D, in fine detail, using a multitude of scanners. The scanners are converging. The old days of, well, you have an X-ray and then you have a CAT scan and then you have some other sort of scan, and ultrasound perhaps, and so on. They're gradually coming together into a machine which does the whole lot. So it's very Star Trek in that sense. It means you can detect things wrong with people before they even know they've got them wrong. And then what do you do about it? Well, do you take a big knife and open them up, or do you give them a pill, or do you do something else? Perhaps use make a small cut in them and deposit, either remove something that's going wrong or deposit a treatment, a pill, a potion, actually at the site that the problem is, and solve it that way. And that's the way we're sort of going forward, which then begs the question, do you need operating theatres, or do you need big imaging departments where you can do this work? So that's changing. What is a treatment room? Well, that overlaps with this interventional imaging business. What's a theatre? And how about barn theatres, where you have several operating tables in the same room? Are they a good idea, a bad idea? Is this improving production, throughput in theatres, because we have an ageing population and maybe we need to get them through quicker? So there's quite a lot of changes that are now happening. The Care Quality Commission independently going around looking at hospitals and critiquing them. Have they got appropriate facilities? Are they looked after appropriately? Were they designed appropriately? Have they been commissioned? And so on. And they're quite ruthless, these people, and it's good. We're having it's a bit like the Nuclear Inspectorate, the Mines Inspectorate. We've got something similar for hospitals now, which is changing the way things are looked at. It's not good enough to say, oh, well, it was built 20 years ago, it's fine. No, it's not fine. So they've taken a hard look. And some of you may know about PAM, the Premises Assurance Model, that's used to judge whether hospitals are up to speed in terms of all their facilities, their management, and so on, their governance, as well as the physical aspects of the hospital. So that's quite a useful model for people actually running hospitals to gauge themselves against. How are they doing? Do they have ventilation? Can they identify what it ventilates? Is it up to a suitable standard? Is it being maintained? Who maintains it? How often? How can they prove it's being maintained? These sort of aspects to it. And then we've had Grenfell and all of that entailed. The inquiry hasn't reported yet, but you don't need much of a crystal ball to guess what the outcome of that's going to be. There's going to be a review of all the fire codes post-Grenfell when the public inquiry reports. They don't want to jump the gun on it. Suffice to say, in writing the HTM, we've had an eye on what's likely to happen, and that's another driver. And NHS Improvements, who are the people who've taken over from NHS Estates, have got a programme at the moment going out to review all HTMs and health building notes. And I've done HTM 0301, and I've also done the engineering parts of HBN 06, which is about, what was 06? Imaging, yeah. I've just done mortuaries, 16. We're doing one on isolation rooms, number 4, and so on. There's a whole range of them, community care premises, surgical facilities. So almost all the health building notes are being changed at the moment. There's quite a big change in terms of what's required on the engineering side, so it's well worth making sure you keep up on that. In terms of 0301, it goes back to 2017. A scoping exercise was done, and the question was asked: do we need to do anything with the HTM, or is it all right as it is? Okay, so the thought was, well, there are all these drivers, we must do something about it. What are we going to do? And the scoping exercise took place over 2 years. I got involved with it, and I got involved with writing the conclusions and so on. Having done that, having consulted widely to do that, we then set about, shall we rewrite the HTM? The thought was we needed to rewrite Part A completely. The old design and commissioning, the design validation part, wasn't adequate. It didn't cover enough. So we've changed the title and we say we want to spell out what the concept is. What are we trying to do in terms of ventilating hospitals, in terms of the design, the specification, installation, and how do we accept them? How do we know we get what we asked for? So the title has changed to quite a long-winded one now, but it spells it out more clearly. And this is a major change. So the whole thing has been completely rewritten. And whilst you may recognise parts of it if you read it, and you're familiar with the other one because a certain amount of cut and paste goes on, in truth, the whole concept of the HTM, the way it's laid out, has changed. So it really needs to be looked at. Part B, it was thought, well, actually, it stood up quite well. This is about the management and operational maintenance of hospitals. But it needed a damp dust, it needed some other bits adding to it, but by and large it stayed the same in terms of format. It stayed the same in terms of minimum standards for air handling units in hospital, because these haven't changed. You know, good maintenance is good maintenance. It hasn't changed at all. The required maintenance hasn't changed. So we spelt it out a little more clearly. But Part B is, you can see if you read it through, it's an upgrade. It's not a complete rewrite by any manner of means, and we didn't feel there needed to be. It's actually stood up quite well. So part of the Part A complete rewrite, we've got COVID. This still goes on. A thought about COVID when we were writing this document, because it came out in the middle of it, was that we can't really say too much about COVID because we don't know. I mean, at one time it was all about wash your hands. So this was a disease transmitted by physical contact. And then it was about, it's on surfaces. You touch a surface and you can catch it. I mean, both of those have been proved to be wrong. Is it airborne? Well, yes, it is airborne. Most respiratory diseases are airborne. Should we make provision for it in the HTM? Well, the thought was, no, we won't. We will leave things until we know what is actually going to work with COVID, and then we will, if necessary, provide a supplement to the HTM specifically about COVID, if we think it's a disease that will continue in future in a way that is going to be a problem, if I can put it that way around. So that's still sort of sitting there. There's work going on at the moment, but the thought was, let's get the HTM done. There are many things that need to be done that we know need to be done. There's the climate change and the zero carbon strategy we need to incorporate in and support. The Part A now gives a good, we hope, explanation of the client and the user's requirements in a way the old HTM didn't. We feel it's necessary to spell out to designers and installers, manufacturers of equipment, why we want ventilation, what matters to us as a client, rather than leaving it for the supplier to tell us what they think we want. And it's one of the problems with some of the earlier PFIs, that we were given hospitals that people thought we wanted, and they weren't what we wanted. If I could be as blunt as that. They weren't. They suited the people who design and build them, but they didn't actually suit the people who had to use them. They weren't necessarily what we needed. And we've sorted that out, but we wanted to try and spell out what we as a client want, what's important to us. There's a lot of misperceptions about hospital ventilation, and we wanted to clarify that. So we tried to do that. There's general employment law and also healthcare legal requirements that weren't being met. We wanted to spell out what mattered to us in that respect as well. There's a design and specification process. We've tried to spell that out more clearly. How do we end up with the hospital we want, with the design we want? And we've introduced a thing called the VSG, the Ventilation Safety Group, which is a multidisciplinary, and I hate that word, but it describes a team of estates people, the designers, the infection control people, the finance people, and so on in a hospital, who get together, and if we want to design ventilation for a hospital, the design has to be passed in front of these people to look at. So it's looked at from all angles. What does it cost? What will it do for us? Will it deliver the goods? Could we maintain it? Is it a sensible thing to have? How does it fit with what we've got? And these people will also look at derogations. So in future, there's problems we've had with derogations where people have derogated things for lots of different reasons. Nowadays, it would have to go to the Ventilation Safety Group. And the reason for derogation has to be recorded and signed up for. It's not good enough to say, oh, we did this in the hospital down the road. Did it work in the hospital down the road? So there's quite a bit there that's new and will involve all of you when you come to do it. Energy and environmental control. How do we control the ventilation in a hospital? Is it all one plant, does the whole hospital, or do we split it down? Do we have central systems, or do we have distributed systems? There are pros and cons for each type, but we've gone through a little bit about that to give some more guidance. And then the equipment selection. What sort of equipment do we want? What fits in with what we want as a client, and what doesn't fit in with what we want as a client? You have quite a few debates about this with manufacturers, because they get very protective about the fact that we have this piece of equipment, we use it in ventilation systems all over the country. We're an internationally recognized company, and you're saying it's not fit for use in a hospital. It isn't about whether what they make and sell is any good or works or not. It's about whether it's suitable for use in a hospital. And one of the biggest problems we have in hospitals is maintenance and maintenance access. If you put equipment in that needs a lot of maintenance, it won't get maintained. And if it doesn't get maintained, it won't work. So then you've wasted your money putting it in. More worryingly is often it becomes dangerous when it doesn't work. Rather than protecting people, it actually causes them problems. And we've had quite a lot of problems with distributed systems, split systems and so on, which have been put in inappropriate places and cannot be maintained because of where they are, because the place is always occupied. You can't get the patients out to do the maintenance, and then they start shedding things that aren't good for the patient. So it isn't a question of attacking companies for the equipment that they're supplying. It's saying that equipment might be perfectly satisfactory in a situation where you can go in every weekend and clean it or do whatever's necessary. But if it's an intensive care unit in a hospital, you can't go in every weekend and clean it. In fact, you can hardly get in there at all. Even in an ordinary ward, it can be very difficult. Given that bed occupancy in hospitals generally runs above 95%, even without COVID or anything like that, or winter flu, it's very, very difficult to get access. So you've got to be careful about what you put in, that it doesn't need a lot of maintenance, or you put it in where you can always get at it without stopping the hospital. And then there's a lot more, there's some information about installation requirements, simple things like I do, as has been said, I've been an authorised engineer. I do acceptance in hospitals. People installing dampers for balancing ventilation systems, and without fail, they put the handle to adjust the damper at the top of the damper. Now, when you put the ceiling up in the room, you can't get at the damper handle to commission it. There's no reason why the handle has to be at the top. It can be at the bottom. The air doesn't know where the damper handle is. It makes no difference to the function of the device, but it does make a heck of a difference if you're trying to commission and balance a system. And subsequently, when the system's in use and you want to clean it and then rebalance it, it becomes almost impossible sometimes to do it properly. So it's simple things like that, as well as the more complicated things that we've tried to flag up. The whole point about commissioning and what should happen has been extensively overhauled, and what is also extensively overhauled is the point about validation. That validation is not just about agreeing that the commissioning people have done their job. Validation is looking at the whole thing holistically and saying, does this deliver what we asked? Is it fit for purpose? Can we use it? And the validator should be appointed by the client, not by the installer, not by the builder, not by the designer, the client. He who pays the piper calls the tune. And the validator is there to look independently at what's done and make sure that it's done correctly. And the validator should have access to the job as it progresses, both looking at the original design to comment on it, although the design risk stays with the designer, but at least the validator should have an eye to what's going on to say, well, I'm not sure that'll work out in reality, or yeah, that's a good idea, whatever. So to advise and help so that on the day that we accept the place, that we know it works. And that's been a big failing. I was asked one day to go and look at a PFI hospital. This was something like 700 bed PFI hospital. And I was asked to go in on a Friday afternoon because they were taking it over on Monday. There is no way you can look at 60 air handling units in that place. And when I said, well, I'll need to look at all of them, I was told, no, well, you tell us which ones you want to look at and we'll let you look at those. Well, I don't even know which ones you've got, so how can I pick one? Oh, we'll pick one for you. No, we want to know whether they works. And this has been a constant headache. So if you look in the new HTM, there's quite a chunk about the appointment of the validator and how the system works. And that ties in with the ventilation safety group as well, to make sure that what was asked for is what gets delivered and it works. So the client's need, we have the building occupants, that's staff, but it's also visitors, it's also contractors coming on site, and it's also patients. We have the building environment. The environment has to be fit for purpose. And it also has to be fit from a point of view of the amount of energy it requires to keep it as a decent environment and how it's controlled. The airborne risks to staff, what are they and how do we mitigate them? And the users' requirements in terms of surgical users, medical users, mental health, etc. The different user groups, also the diagnostic and support services. There is often a perception that, oh, well, if we filter the air, if we put enough air in the hospital and filter it when it goes in, nobody will get ill. That's an absolute nonsense, because almost all of the things that make people ill in hospitals in the airborne route are shed by people in the hospital. People are the source of the problem, not the air coming in from the car park. Even if you didn't filter it, it would be fine. The hospital wouldn't stay clean very long, but you're unlikely to catch anything nasty from the air coming in from outside. The problem is people inside. So how you ventilate the hospital in order to dilute and control what is being shed by the people using it is what really matters. And that then runs into things like diagnostic and support services, where they may need particular conditions in order for their equipment to work correctly and accurately. We have quite a lot of legal requirements in the hospital. HASWA you're all familiar with. Notice there's a duty of care. Notice it's on the employer, owner, operator and supplier and the employee. Notice COSH, it also has local exhaust ventilation and Legionnaire's disease. We have a lot of things in a hospital where we use the movement of air to control a hazard. We use them in safety cabinets, in laboratories, all sorts of places. So COSH affects us quite a significant amount. We've got the workplace health, safety and welfare regs. They say we've got to maintain the system efficiency. We've got to provide ventilation in the workplace. And we've also got the building regulations, which are about to be changed because of COVID. The provision of ventilation, minimum standards, and so on. There's a whole lot of legal requirements which often people have ignored. And I have to say the health service has been its worst enemy over the years, because often it felt, oh, these things don't apply to us. Well, they do. Very importantly, they do. You've also got, just to make life more difficult for those of us who work in hospitals, the Health and Social Care Act. We're supposed to assess the risk, prevent, detect and control the spread of infections, including healthcare associated infections. And our premises must, and it's a legal requirement, be clean, secure, suitable, properly used, maintained and appropriately located. So that's got a lot of knockback in terms of what we actually build, how we put the ventilation plant in, how we ventilate it, as well as all the other services in the hospital, as you'll appreciate. So we're boxed in by both the sort of thing that everybody else is, the health and safety at work and the rest of it, and also our own acts, the Social Care Act. And we have as well the Medicine Act. The premises have to conform to specific guidance and they have to keep accurate records of plant performance. Again, these are legal requirements. We have no choice on it. We have to do it. So we've tried to spell these out more clearly in the HTM so that people understand why we might be asking for specific things. There's a requirement for us to do so. The design and specification process we've tried to spell out. How do you get the project brief? Where's that come from? What should be in it? The role of the ventilation safety group, already mentioned. Derogations, they have to go through the ventilation safety group. I recently been doing a hospital in the Republic of Ireland, a new children's hospital, and I was told when I went to a meeting, before they'd even dug a hole in the ground to start the foundations, when I did a critique of the ventilation, oh, well, they're all been derogated. I said, where's the list of derogations? Oh, we haven't got one. So what are they? Well, we got a list somewhere. Well, who did this? Oh, that was done some years ago. It was like knitting fog. You couldn't get your hand on it. No, that's not acceptable. These days, from now on, your derogation has to be written down, what it is, why the derogation's there, and who has said it's okay to be derogated, and that would be the ventilation safety group. And bear in mind, you can derogate up as well as down. It may be that the local hospital wants something more than is required in the HTM. So the derogation might be that you want something slightly different in an increase over the HTM's requirement, not just a reduction. Resilience and diversity is a big issue at the moment. We need systems that work and are reliable. We need systems that will continue to work, that don't let us down. So, for instance, we now ask for fans to be changed within 20 minutes. So we want fans to be plug and play. You know, we've got rid of, or we're getting rid of, hopefully, all the belt and pulley driven fans. With modern plug fans and EC fans, there's no reason why they can't be pre-wired and just swap them over and plug them in and off they go again. So we want to take advantage of that because we don't have the time. Putting in two fans, twin fans, doesn't actually give you resilience. You've still got to change the thing and shut everything off to change it. Having one fan that you can change quickly gives you more resilience than having two fans or run the standby. And diversity. Again, often a lot of hospitals, too many eggs are in one basket. You have an intensive care unit. It's all served by one air handling unit. It's single point failure. If that unit fails, you've lost the intensive care unit. And because it's an intensive care unit, you can't just move the patients somewhere else, perhaps. So if you're going to have one air handling unit for the intensive care, you need another area in the hospital which has the services intensive care need. You can put your patients to, or you split the load on intensive care into two air handling units and serve half from one and half from another. It's not difficult, but it's just accepting that things will go wrong. They will break down, they will need maintenance routinely to be shut down, to be looked after and so on. And you might have a fire or an incident in the hospital, which means you've got to move. Where are you going to put these patients? Have you made provision for it in terms of ventilation and the other services? For new builds, we've got some more information. We've also got some information about when you do refurbishments, because there's been quite a few places where refurbishment hasn't been appropriate, and the change of use. Again, we have a problem with people changing the use of areas in a hospital. A scheme is done and it's said, oh, leave the ventilation as it is. Well, maybe the ventilation is more than's required. So now we're just going to waste energy for no good reason. So the ventilation needs to be considered. The refurbishments, it's a routine thing. I know some of you have been involved with me in projects where a theatre has been refurbished and it's all been nicely done out, and new operating lamps, new control, new surgeon's panel, new operating table, you name it. Same old air handling unit. It was already 20 years old. Oh, we can't afford to change the air handling unit. Well, in that case, you can't afford to do the refurbishment. So we're trying to nail that sort of thing where we've got air handling units that are 30, 40 years old on top of somewhere that's been refurbished 2 or 3 times. You need to do the whole thing. Use of CAD and BIM and the use of soft landings. Some of you will have used soft landings. Soft landings is about keeping right through the project an eye on what the customer needs, so that when you arrive at the end, you haven't forgotten what they needed. You haven't been driven off course because of site conditions, labour problems, supply problems, things like COVID coming up. So that's an important aspect. And the strategies for controlling ventilation in terms of zoning and the control of it. We've extended the section on operating suites with an explanation of specific room functions. Again, I think we've been guilty, the health service, of assuming people know what we want and what's important to us. Well, I've tried to come away from that and completely rewrite this to spell out, not quite Noddy's guide, but at least that people understand what it is we need. What do we use this room for? What is the problem? Why are we ventilating it? What matters? We've revised the air volumes and air change rates to benefit from the fact that we've got better fans and control technology. We used to want 25 air changes in a theatre. We're now saying 22. It's not that things are getting worse. We only really needed 20. But if you have a belt and pulley driven fan, you need quite a bit of elbow room there, because over its life, it will the performance will drop off quite significantly. And so if you don't start off with a bit of cushion, you're going to end up after a few years not achieving a minimum standard that you want. So we've tried to say, okay, now we've got better fan, better technology, we can come a little closer to what we want, and we can control the output of the fan over its life much more accurately. So we can use less energy, we can benefit from the new technology that's available to us. I've clarified the volume of theatres. This has been a perennial, those of you involved with theatre design. How big is the theatre? Do you include the scrub? Do you not include the scrub? And so on. So we've tried to clarify that one out. And we revised the appendices with the design of theatres significantly. If you do get into theatre design, please look through them carefully. We've expanded them and tried to add some explanations as well. I've revised the standard operating theatre layouts, and I've also retained some of the older layouts for if you're doing refurbishments and so on, with guidance on what to do about that. And clarified clean airflow paths in anaesthetic rooms. There's been a big problem. Anaesthetic agents are subject to COSH, but people weren't designing properly. One of the reasons that our good friends Carillion went to the wall was that when the last hospital they were building, they didn't put in the ventilation correctly in the operating suites, and they didn't put it in correctly, in particular in the anaesthetic rooms, and the airflow wasn't a clean airflow path in terms of the people using the room. The airflow dragged anaesthetic gas past the breathing zone of the anaesthetist and took it out on the ceiling, because the extract was up on the ceiling and it was behind the anaesthetist, not in front of them. It shouldn't have been on the ceiling anyway, and the airflow path certainly was in the wrong direction. So although that was pointed out very early on in that project, that's what they were doing this wrong, they persisted in saying they were right. Turns out they were wrong, and not long afterwards they ceased to be a problem, shall we say. I've put in Appendix 9, which is an addition about anaesthetic rooms as an example, where we put the supply terminal, where we put the extract terminal. That's what we want to give us a clean airflow path. So clean air comes out the ceiling, past the anaesthetist, who's probably standing up, past the patient, who's probably lying down, and down towards the where the anaesthetic gas terminals are. And that's probably where most of the waste anaesthetic or loose anaesthetic gas spill will be, because anaesthetic gas is slightly heavier than air, so it tends to sink if you leave it alone. And so we want to encourage that to go on and make sure that we've taken all reasonable and practicable steps to protect our staff from exposure to anaesthetic gas. Because whilst anaesthetic gas is very good if you're having your legs sawn off, it's not so good if you breathe it in all day long. It's not good for you at all. And so we've done it that way. So that's in there. And a similar thing occurs in maternity and other places where anaesthetic agents are used. You need to establish a clean airflow path, and we've tried to spell this out a lot more clearly. This is a problem in anaesthetic rooms. Here's an anaesthetist trolley. They do like their stuff, anaesthetists. They do like to have lots of spare bits. To the left at the bottom of that picture, you can see that's a grill covering a pressure stabilizer that's supposed to allow air to go out the corridor. Plainly, not much is going to go out that way because of the way it's put in. It's not that the airflow path isn't there, it's just that when in use, it's not going to be there. That's the reality. We've put in this as this sort of thing. If you put an extract in at low level and cut it back at an angle, and you stop it short of the floor, you don't add complications to making the floor. There's no more corners to go around. You can still clean around it, and you're unlikely to obstruct it. That's an even better one. Just to show, this was done in the hospital. It doesn't cost any more to do this, but it means that the terminal is accessible to be measured with the bolometer. In this case, you can pull the front off to clean it because it will get fluffy and dusty, and there's no complication on the floor in terms of cleaning or even laying the floor and coving it. So these aren't rocket science, for goodness sake, but this is just good design that enables us to achieve our cost requirement and also not make things more complicated than need to be, and make it simpler to prove that the system works. This is just to show you some research we did about scrub troughs. We're simulating here someone with a shocking cold who's scrubbing up at a trough. You can see there are extract terminals below the trough. Droplets of moisture when you're scrubbing up tend to fall. If you put your extract down at low level under the trough, it tends to drag it down there anyway and get rid of it. If you put your extract on the ceiling, it tends to drag it up and chuck it all over the room. So this is not difficult things. These are what we're after. Quite simple things. We know they work because we've spent time doing research to find out. This is a classic design error, if you like. Here's a scrub. There's a pressure stabilizer up there on the wall on the top left-hand corner. To let the air out. There's also extracts under the scrub. Looks all right, but then that's what's the other side of that stabilizer. So it actually lets out into an anaesthetic room next door. So you are the patient being anaesthetized, and you can hear the surgeon and their mate scrubbing up and talking. And they're telling each other, have you done one of these before? Well, not for months. The last one I had, he died in the middle of it. His leg fell off. I can't quite remember. You know, there's more to it than just moving the air. You have to think, when I talked to this designer, he said, well, there was no easy way of getting the air out. Well, yes, there was. He could have ducted it up to the ceiling. There is a loose fit ceiling there. He could have gone up the ceiling and out, but he didn't. So you've got to bear in mind that you don't want people to hear things. You don't want to put them off when they're going in for an operation. It's worrying enough without that. So this is sort of, again, not rocket science. It's sensible enough. It's basic enough stuff. We produced as well to try and help application-specific guidance. So whilst the HTM has a lot of information on theatres, and the reason is that theatres are a linked series of rooms where the air cascades from one room to another, and there's a pressure relationship between those rooms. So if you understand that, everything else is actually a lot simpler. That's as difficult as it gets. So we produce specific guidance on treatment and procedure facilities, on airborne protective facilities, where we want to protect people from airborne hazards coming into them, people who are on treatment for cancer and so on. The chemotherapy will ruin their immune system, so you need to protect them. Airborne isolation. Similarly, maternity, pharmacy, sterile services, and extract systems for LEV. So we've given a lot more detail. I produced it in this form in the HTM. I hope you'll find this a little more useful. So if you look along the top there, applications, isolation rooms, category 2 and 3, and infectious disease units and containment level 3 rooms. Categories 1, 2 and 3 and 4 for illnesses. Category 1 is you, it's human beings, if you like. We're not dangerous to each other, not in the microorganism sense anyway. Category 2 is, if you like, the common cold. Category 3 would be COVID, and Category 4 would be the Black Death. So just to give you a feel for, depends how ill you are and whether when you spread it to other people, you're likely to kill them or just make them ill. So if you look down the left-hand side, we've got the area or zone that we're talking about. Next to that, we've got why are we ventilating? We've got an explanation of why we want to ventilate, and where you can get some other guidance as well. And then over on the right-hand side, typical, and these are typical design factors when you're ventilating. Where should you put the ventilation? What should it be doing? Okay, so hopefully that will give people more of a steer, and there's a sheet like this for each of those different setups, as it were, in the hospital. So it hopefully will help you when it comes to doing a design to understand what's required, why it's required, and what's typical, what's a good number to use, shall we say, in terms of designing. The equipment selection gives quite a chunk about plant locations and safe access. I'm quite worried about access. We've had a lot of problems with our staff getting hurt because people have very poor access to air handling units. They've got to be installed to permit maintenance. Identification and labelling of systems is very important. Again, a lot of hospitals, you go there, they may have 50 air handling units. They have 5 of them all labelled number 1, and about another 5 labelled number 2, and so on. Trying to get away from that. Minimum standards for construction, standards for installation, air distribution, and automatic control. So it's quite a chunk in there for the people who make them. Please note, it's been released on the 22nd of June, so it's now in. It applies to all new designs and refurbishments of existing designs. Most existing hospitals were designed to 0301, 2007. You do not have to change them. People have been panicking, you've got to bring them up to date. No, you don't, unless you upgrade the system and do a refurbishment. You might want to, if you're in the middle of a contract that was signed and you haven't actually done anything, I mean, nothing's been physically done, it might be an idea to run your eye over the new HTM and discuss with the client whether they want to move to the new one or stay with the old one, and what that might mean financially in contractual terms. It might mean no difference. It might mean somebody has to find some more money or even some less money. Who knows? But it's worth considering, but you'd need to agree that if you've already signed for the job with your client. That's a mutual thing, but there's no requirement to do it. And lastly, part B is concerned with operational management and minimum standards and applies to all systems, no matter when installed. And a lot of people say, oh, I've got a system was installed under HTM 2025, HTM 0301 doesn't apply to me. Yes, it does. It doesn't matter when it was installed, because the basic standards have not changed since about 1985. So you shouldn't have any plant in that doesn't conform to them at this stage in the game. Lastly, or in conclusion, there's an entirely revised format in this HTM with many changes. Please read the lot and not just Part A, Appendix 2. There's more to it than one sheet of paper at the back. Okay, thanks very much. I'm here if you want me to answer questions.
Malcolm,
Escape from that.
I'm getting some feedback. No, it's very important to see the background. Sorry, I'm still getting. And also gone into your. I'll ask people to do some questions in the chat. But just to start off, are you getting feedback?
I'm getting you sound like what's his name? He used to Yeah, anyway, you're breaking up. You're coming and going.
Okay.
Norman Collier, wasn't it? Yes, used
Norman
to do
Collier
the
with
interrupted mic. I'm showing my age. I knew if you remember Norman Collier. There you go. Hot pies are ready. Yes, him.
If I could just ask an initial question. I'm glad you picked up on the validation. It's always frustrating as a designer for the validator to come on right at the very end. And obviously find problems with the system. And as consultant engineers, we're always trying to encourage clients to get the validator engineer on board with that use that you pick up on. Could you just tell me a little bit more about ventilation safety and what their authority and how that is implemented?
Well, because this is new, plainly not all trusts have a ventilation safety group at the moment. They are coming into being, can I put it that way? If you've dealt with the water safety group, yeah, over Legionella, they've been going for a while, as the electrical safety group have. So it'll be the same, it's the same thing. It'll be the group of interested people who have an eye on what's going on and are charged with making sure collectively that they understand what they're asking for and what they're going to get with the design. And really it ties in with the whole thing about the validator, getting the validator sorted out early enough so the validator can be part of that process and see what's going on, so they know what's been accepted, what has been perhaps rejected, what the aim of the project was. And that chimes in with the soft landing approach, yeah, which is the same idea. We try not to lose sight of what we set out to do. Yeah? And unfortunately, I have to say, in defence of people like yourself and other project managers and the rest, the clients are sometimes their own worst enemy, because they won't appoint the validator until right at the end of the project. And then, I mean, I got told off with a project that I did, and I said to the chief executive, do not accept this hospital, it's not ready. And she said, you are not going to stop me moving in on time, Malcolm. Right? You pay me to tell you, you've got an old hospital over there, but it's a goodie. It all works. It may be old, but it's a goodie. And you've got a new one here, and it looks lovely, and it's absolute crap. You know, it doesn't work. And you're going to move patients from an old one to a new one, from one that worked to one that doesn't, and you shouldn't do it. And I got told, no, we won't use you again. So, and I think, well, fine. I didn't ask you anyway.
There's a question here from Mike Dunn, and he's touching on timings and kind of half mentioning this. The new HTM from June 2021 for all new sites. But where do we draw the line?
Well, I think if you've not signed a contract, it's clear that if you've not signed anything before at the 22nd of June, you are now on the new HTM. If you've signed financial close, then plainly you can say, well, that was on the basis of the old one, and that's where you need to perhaps sit down and have a chat with your client about where you go from here. Does it benefit both of you to move to the new HTM, or at least part of it, or whatever? Yeah, I think that's an individual horses for courses. I know we had this when the old HTM 0301 came out, and we were on HTM 2025, and there were a lot of crossover projects at the time. And some clients said, no, actually, I'd rather be as up to date as I can, because we haven't actually built anything yet. We're still, although we signed off, we haven't actually physically built anything. Or even if we have, the people making our air handling units, we had a chat with them, and they say, yeah, we can do that. That's not a problem. We can fix that. We knew it was coming, so we've already redesigned for it. Because bear in mind, as with this one, there was a lot of consultation with the people who make stuff. Yeah, so it didn't come out of the blue. It's been a 4-year process, this. And so, and the concepts of moving from, let's say, you know, belt drive fans, I mean, is that new? You know, we've had EC fans for a long time now. We are moving towards fan walls, which would be a different thing again when it comes. But, you know, the idea of that we're going to use EC or plug fans rather than belt fans, that's not new. So already there's a lot of things in the pipeline, I think. So I would say you need to sit and chat about it if you think there's a problem, and be sensible.
All right, I've got. So I think the feedback coming from your microphone.
My microphone.
Yeah, just use it while I'm asking a question. See if that works. Okay, I think that's sorted it. I've got a very specific question here from Nick Boardman. He says, how large should the writing be on the traverse labels?
Well, if he reads the HTM, it's 100 mil on the main air handling unit, and it should be similarly on the major distribution ducts. So that when we're talking about that, we're talking about the ductwork in the plant room. Now, plainly, if the distribution duct is only 50 mil, then you're not going to get a 100 mil label on. The idea here really is I want to be able to see it. I don't want to have to guess what the airflow is. What's the design flow? Where's my test point? Yeah, I want to be able to see it. I'm a human being in a plant room, and there's lots of other things in the plant room. So I don't think anybody's going to beat you up if you put a 50 millimeter on a small duct. That'll be fine. But can you easily see it? That's what it's about. And I would say a lot of this, it's like we ask for plant rooms to be labelled. We ask for a list of plant in the plant room to be at the plant room entrance. This is what I would call as having been a hospital engineer, 3 o'clock in the morning information. When I am called out because things have gone wrong, I am half asleep. I need all the help I can get. So can you make it as simple as possible? That's really what we're after. So, okay. All right.
Yeah, that's great. Question from Christopher Jones. He said that you mentioned the theatres changed from 25 to 22. Is this across the board for UCV and conventional?
That's the base air change rate for conventional and UCV. Plainly UCV recirculate air, so that's just your primary air supply, would be at no less than 22 for design. It's usually more than that anyway for lots of, we'll get the technicalities of it, but that would be the minimum primary air supply in both types of theatre.
Okay, that's brilliant. Thank you very much. Yeah, just one last question for me before we wrap it up. And if anybody else has got any more questions, please do post them. You mentioned the healthcare associated infection, and I wondered what changes that you'd made to HTM03 to deal with that particular subject matter.
A lot of it is to do with accessibility of plant for maintenance, because often these are tied up with ill-maintained plant or poorly maintained or plant that's never been maintained at all because you just can't get at it. So that's a major issue. People who put plant and equipment up in ceilings above beds. People who use the return air, examples I've run up against, investigated, using a ceiling as a return air path. So they're picking up aspergillus from the ceiling. Yeah. These things have led to problems. So without getting into medical legal, we don't want to end up in court. But you know, there's a lot of things like that, and at the end of the day, they're really very simple.
Okay, I was thinking it was perhaps more to do with the quantity of air that you're introducing, but actually it's more of an issue about maintainability, to keep the system that has been designed, keeping it going in a correct manner.
Yeah, well, and you touch on the quantity of air. One hospital I went to had HEPA filters in their air distribution system in every corridor. And no way could anybody, I mean, the hospital didn't even know they were there until I did an inspection of it. And they'd never been changed.
No, it happens.
And the airflow was almost non-existent. So, you know, where's the problem? Is it low airflow? Is it because you can't do your maintenance?
Yeah.
And it was inappropriate anyway to put HEPA filters in. That was a whole nother issue. But that's a sort of circular problem, isn't it?
Oh, indeed. Okay, well, I think we'll probably wrap it up there, Malcolm, if that's okay. I think everybody seems to be very pleased with the presentation. I must say thank you very much for that. It was very informative. It's filled a load of gaps, I'm sure. Some people have asked a question about the slides. Would they be available? If they are available, Malcolm, I can easily send them on if that's okay with you. And somebody's asked a question about, is the video available? I can make that available also. So once again, on behalf of CIBSE, Malcolm, thank you very much, and I hope to see you soon.